Okay, so let's have a look at the product. Over the next few minutes, I'm going to take you through some of the differentiators of SimScale. And I'm going to combine that with doing some short demonstrations on the platform itself. So the first differentiator of SimScale is the fact that SimScale is completely cloud native. You don't need any VPN or remote desktop to access SimScale. You also don't need any locally installed software or hardware. So all I need to do to access SimScale is go to simscale.com and then log in. From there I can see the projects that I've been running, and you've got unlimited storage space available in SimScale. What we're going to do for this demo is have a look at a motor assembly, an electrical motor. And for the first part of this demo, we're going to have a look at the cooling channel, and we're going to optimize that by having a look at the pressure drop through it, and then we could obviously choose the design. So the first thing to do is to obviously import your geometry into SimScale, and we support all major CAD formats as well as intermediary formats. Once you've got your CAD geometry into SimScale, you can also do some basic edits and changes to the CAD to prepare it for simulation. So here I just want to extract the fluid volume for the cooling channel and isolate that so that we can do a pressure drop analysis through it. When you go to then create a simulation, you can choose from the various simulation types that are available. There's flow simulations, structural simulations, and electrical magnetic simulation types as well. I'll go into this in a bit more detail later on. But I'm going to choose the subsonic analysis type, which is a great option for flow control and analysis of pressure through systems and rotating machinery. As with many simulation tools, what you're looking to do is go through the simulation structure to get a green tick against everything. And in this circumstance, I'm going to be assigning a parametric flow rate to the system here. So I'm going to enter multiple flow rates, and then SimScale will simulate all of these different operating conditions in parallel and provide the results to us. So I just need to assign a couple of boundary conditions. I've already assigned the material, and then basically we're ready to go. The final thing I'm going to do is add some result control so that we can see the pressure difference across the system for those various operating points. Now that's all set up, I can run the simulation. SimScale is very good at recognizing if there's anything wrong with the setup so that you don't waste your time running an incompatible setup. We can see here that I've got a warning that gravity isn't defined, but in this circumstance I'm not concerned about that. So I've set off the simulation, and I've got 3 simulations running in parallel there, and I'll get an email notification once those simulations are complete, and we'll be able to check in a bit further along in this demo to see how those simulations are doing. Okay, so the second differentiator that I want to talk to you about today is the fact that SimScale is one single platform with broad physics capabilities. There's no disconnected tools that you have to open up to do a structural analysis compared to a flow analysis. Everything is available in one UI. So in this demo, we're looking at flow analysis, electromagnetics, thermal, and structural analysis capabilities. So let's have a look back in our project here for the electrical motor. For this specific example, we've run a structural analysis to analyze the stresses on the rotor, the static structural stresses. And we've also run thermal analysis to look at how effectively this motor is cooled, doing a conjugate heat transfer analysis that also takes into account the Joule heating from the electrical conduction through the coils in this motor assembly. We've looked at some dynamic analysis as well to analyze how this shaft performs under various natural frequencies and harmonic analysis as well. And we've studied the electromagnetic capabilities of this motor as well. to see what the force would be at different currents assigned to the coils as the motor is being used in service. So there's many different physics that we can look at, and we're also now running the pure flow analysis, which is now, as you can see, 33% complete. So we'll check back in to see how that's doing in a couple of minutes. All right, so the third differentiator that I want to have a look at with you is a couple of benefits that come from SimScale being completely cloud native. So because SimScale is completely in the cloud, it makes collaboration and data sharing so much easier. If you want to invite someone from a different geographical location or from a different office to collaborate with you on a project, you just need to invite them, and then they can log in and see that same data live in the platform. They don't need to transfer large data files. They can just immediately access that same data. Also, it opens up the ability for us to be able to provide real-time support to our customers as well. So let's have a look in the platform, specifically how that works. So in this project, say for example I'm not an electromagnetics expert, I want to invite a colleague of mine into the project. I just put in their email or their username and define their level of access. And then this invites them into the project. They get an email notification, and then they can come and collaborate on this project with us. At the top of the screen, we can see another user has entered this project, the user that I invited, and then they can choose whether they're going to collaborate with us or just see the setup that we've got, and everything can be done in real time. The other great benefit that comes from being cloud-based, as I mentioned, is the fact that we can provide real-time support. So there's no need to raise help desk tickets. You can just chat directly with us in the software, and then we've got engineers on the other side waiting to answer your questions. Typically, they respond within a few minutes in business hours to provide you with an answer to your query. So it's much faster and much more collaborative than a ticket-based system. Okay, and the fourth differentiator of SimScale is the fact that SimScale is AI-powered. Thanks to our collaboration with Navasto, you can run machine learning-based models on graph neural networks to predict what the simulation results would be for a specific simulation. Also, the fact that you have all of your data saved in SimScale means that you're AI ready. You can use your simulation data that you've already got to produce machine learning models. Let's have a look at how this works in SimScale. In order to demo this, I've got a muffler model here. I've run a DOE study in advance to train a graph neural network on this muffler model. And I could go through and run a traditional simulation here and get the results back in about 10 minutes. But I can also use the machine learning model that I've now trained to get instantaneous predictions of what the simulation results would be. So I can see here different result fields. I can see the pressure predicted for this muffler, and these results are live as well. So I can scale the results and see how that appears. And the beauty of this is I can bring in any CAD and assign this prediction, or I can change the boundary conditions. I can change the velocity and see the effect that that would have. So here we see a completely different CAD, again with an instantaneous prediction of what the results would be. And maybe I could change the flow rate as well here to see how that would have an impact on the result. So you can iterate very quickly at an early stage in the design process using these ML-based models to predict what the results would be. Obviously, I guess you're asking how accurate this is, but here we can see an example of a side-by-side comparison for this muffler. So on the left-hand side, we see the actual simulation result in SimScale, and on the right-hand side, we can see the prediction of what that result would be. And there's obviously a very good correlation here. Okay, and the final differentiator that I want to cover with you today is the fact that SimScale operates on any scale. And this is applicable for a couple of different reasons. You can invite anyone in to use SimScale in your organization, and they don't need any specialist hardware or software to run simulations. Everything I've been showing you has just been in my web browser. Also, you have unlimited parallelization capabilities. So you can scale your simulation use as an individual user from one day to the next. Maybe one day all I want to do is run a structural analysis, a simple static structural analysis, but then maybe the next day I want to run many different CFD simulations in parallel. I can very easily do that. Here you can see this experiment run that I set up, completed in 4 minutes, and I can see the pressure result from those runs. I can see my 3 individual points from those simulations, and I can obviously go in and post-process those results to obtain the results that I'm interested in. Here I'd probably want to see the pressure so that I can understand what the pressure drop would be through the system here. So it's very straightforward. I could have run hundreds of simulations in parallel and they all would have finished in the same time. Just touching on one of the previous points, you can see that our support engineer has responded to my question that I asked within a few minutes, and he's available to support me directly with this project. Okay, thanks for that.